Imagine tearing a crucial ligament.
Oh, yeah. That is a brutal experience.
Right. I mean, in the traditional medical world, an injury like that benches you for like 6 to 8 months. You are looking at a grueling timeline of surgery, immobilization, and, painful physical therapy.
We're just universally conditioned to accept those strict biological speed limits.
Exactly. But then, if you listen closely to the whispers in the elite athletic community or among intense biohackers who are pushing the limits of human performance, you start hearing these crazy stories.
Stories about people magically bouncing back.
Yeah, bouncing back from catastrophic injuries in just a fraction of the expected time. To conventional medicine, it sounds impossible, but to the underground world of experimental regeneration, it's just becoming a Tuesday.
It really represents the absolute cutting edge of regenerative research right now.
So welcome to today's deep dive. We have compiled a massive stack of research, including a really comprehensive guide by Nikki Chase over at Era Organics, to explore this fascinating and honestly somewhat mysterious molecule known as the TB-500 peptide.
If we connect this to the bigger picture, TB-500 acts as a synthetic shortcut to our body's own natural healing processes.
Which is wild to think about.
It is. We are essentially learning the chemical language that tells our cells how to repair themselves. However, I want to make sure anyone diving into this topic with us understand that this molecule currently sits in a very vast, unregulated gray area.
Yeah, that is a huge point to make up front.
It's heavily restricted to laboratory and research applications. It completely lacks large-scale human clinical trials. And its legal status varies significantly depending on what country you happen to live in.
So we are really operating on the experimental frontier here. Today, our mission is to walk you through exactly what this compound is. We are going to explore where this peptide actually originated, how it operates on a microscopic level, and why people are risking so much to use it.
And crucially, the very real safety concerns that come with forcefully bypassing your body's natural speed limits.
Okay, let's unpack this. We have to start with the origin story because, well, to understand the power of TB-500, we first need to know where it comes from. And diving into the research, I was genuinely surprised to find out that the genesis of this futuristic biohack is actually tied to cows.
Yeah, the bovine connection. The scientific journey does begin in the mid-20th century with bovine, or cow, thymus gland tissue.
The thymus gland.
Right. Researchers were heavily focused on the thymus gland at the time because it basically serves as an absolutely critical training camp for the immune system.
Okay, I see.
It regulates tissue development and immune response. And while analyzing this bovine tissue, scientists isolated a naturally occurring, highly complex protein, which they named thymosin beta-4.
Thymosin beta-4.
Got it. They observed something really remarkable about it, too. It was present in incredibly high concentrations within blood platelets and white blood cells.
And those are the body's first responders, right?
Exactly. Whenever trauma occurred in the body, those cells would release thymosin beta-4 to rush to the site of the injury almost immediately.
Wait, so are biohackers today literally relying on extracts from cow glands? I mean, how are people actually getting their hands on this?
Oh, no. Modern chemistry totally eliminates the need for animal extraction. Today's manufacturing doesn't even attempt to replicate that entire massive thymosin beta-4 protein.
Ooh, they don't?
No. Through advanced synthesis, scientists discovered they only needed a tiny isolated snippet of it. They zeroed in on a specific amino acid sequence, specifically positions 17 through 23 on the protein chain.
Just that one little section.
Yeah, just that microscopic synthetic fragment. And that is what we call TB-500. It turns out that specific sequence holds the primary biological key that unlocks the massive regenerative activity they were looking for.
And unlocking that regenerative activity comes down to this biological mechanism called actin sequestration, which I admit sounds like incredibly dense textbook jargon.
It definitely does.
But breaking it down actually reveals a really elegant process. I want you to visualize a single human cell as a busy construction site.
Okay, I like this analogy.
So actin is essentially your raw building material. It forms the scaffolding, the beams, and the bricks that allow a cell to physically change its shape, divide, and move to where it is desperately needed, like a torn muscle fiber.
But biology is messy.
Exactly. Left to their own devices, these raw actin building blocks have a tendency to just, well, spontaneously clump together. They form these long, disorganized, useless filaments that pile up on the construction site and halt all progress.
And that clumping creates a massive bottleneck in the healing process. When trauma occurs, your body desperately needs those raw materials to be fluid and readily available to rebuild the cellular matrix.
Which is exactly where our peptide steps in. If actin is the raw building material, TB-500 is the hyper-efficient project manager.
The one keeping everyone in line.
Right. It physically binds to these individual actin blocks, and that is the sequestration part of the scientific term. By binding to them, it prevents them from clumping together into useless piles.
It keeps the supply chain moving.
Yes. The project manager ensures there is a perfectly steady, highly mobile supply of raw materials being rushed straight to the damaged tissue.
And because those materials are no longer clumping, they trigger a whole cascade of secondary regenerative effects. Supplying the building blocks is really only half the battle.
What's the other half?
Well, a construction site also needs robust supply lines to deliver nutrients and clear out waste. That requires a biological process known as angiogenesis.
Angiogenesis. Laying down a whole new system of pipes.
Exactly. Building those new pipes requires the stimulation of endothelial cells.
Remind me, those are the ones lining the blood vessels.
Yeah, the specialized flat cells that line the entire interior surface of your blood vessels. The peptide sends this powerful chemical signal, forcing these endothelial cells to rapidly divide and form entirely new capillary networks.
So it's literally commanding the body to build new blood vessels from scratch.
From scratch. And this is particularly vital for connective tissues like tendons and ligaments. Those areas are notoriously slow to heal because they naturally possess terrible blood flow. They sort of exist in these cold, low-oxygen environments.
Right. They just don't get the nutrients they need to fix themselves.
Exactly. By forcing the construction of new vascular networks, the peptide ensures that oxygen, repair cells, and vital nutrients can actually penetrate the dense tissue of a trauma site.
I mean, that low oxygen environment totally explains why a torn Achilles tendon takes an absolute eternity to heal compared to, like, a simple scrape on your arm.
It really does.
And it perfectly explains why this specific peptide has become such a massive, highly sought-after tool in the performant lifestyle community.
Right.
If you are someone who constantly pushes your physical limits, a competitive bodybuilder, an ultra-marathoner, or just someone dedicated to extreme HII workouts, you are intentionally creating micro tears in your muscle tissue every single day.
You are placing a massive daily demand on your body.
Right, you're demanding that it rebuild cellular scaffolding and lay down new blood networks overnight.
And the physiological demands of that lifestyle align perfectly with the molecular benefits we are seeing here. The research indicates that the peptide upregulates actin-binding proteins.
Upregulation just meaning it turns up the volume on the process, right?
Exactly, increasing the cellular response rate, which vastly accelerates the migration of repair cells to those daily microtears. And beyond just muscle fiber, it heavily stimulates fibroblasts to increase the production of collagen.
And collagen is basically the foundational protein structure required for soft tissue recovery and elasticity?
Correct. But it even goes beyond just the structural scaffolding. The research notes that TB-500 actively signals the cells within the joint capsule to increase the production of hyaluronic acid.
Oh, wow. So it creates thick, lubricating fluids.
Yeah. It is essentially greasing the hinges of your joints to support long-term mobility and flexibility under really heavy loads. It repairs the microscopic wear and tear in ligaments before those tiny fissures can cascade into a catastrophic career-ending injury.
And a really critical differentiator of TB-500 compared to other treatments is its systemic nature, right?
That is a massive factor. This synthetic peptide has an exceptionally low molecular weight.
It's tiny.
Tiny. This tiny size allows it to travel freely and rapidly throughout the entire bloodstream. It doesn't just remain isolated at the injection site, it circulates systematically, hunting down inflammation, reaching distant tissues, and repairing damaged fibers regardless of how it originally entered the body.
That is wild.
It even demonstrates a remarkable secondary ability to prevent apoptosis, which is the biological term for programmed cell death, in otherwise healthy cells that happen to be located adjacent to a severe trauma site.
So it actively protects the healthy neighborhood while it reconstructs the damaged house?
That's a great way to put it.
But, this all sounds like a literal miracle, and this is exactly where my skepticism kicks in hard. What does this actually mean for the everyday athlete trying to push their limits?
That's the million-dollar question?
The research claims this systemic healing decreases injury frequency over time and vastly improves overall tissue durability. But if someone is using a highly potent biological shortcut to prevent overtraining syndrome, Aren't they fundamentally just masking their body's desperate natural demand for rest?
You've hit the nail on the head.
I mean, if you are chemically forcing your cells to constantly rebuild and lay down new blood vessels without ever taking a recovery day, I have to wonder if that is genuine healing or if that is just muting your body's built-in alarm system before the whole engine blows up.
Overriding physiological limits constantly is a deeply concerning premise. The biological shortcut undoubtedly allows for a much more frequent, intensely demanding workout schedule by rapidly clearing systemic inflammation.
And flushing out metabolic waste through those new blood vessels.
It's exactly. However, tissue regeneration requires a massive amount of metabolic energy. Continuously and artificially accelerating that process over months or years could provoke systemic consequences we haven't even begun to map out.
Which is terrifying.
It is. Responsible researchers focus heavily on the delicate balance between breaking tissue down and allowing adequate time for physiological recovery. They recognize that peptides are a tool, not a replacement for rest.
Okay, so if this systemic healer is as powerful as the research suggests, I bet a lot of people are wondering why they can't just buy it in a sports drink or, like, pop a pill with their morning vitamins.
Oh, if only it were that easy.
Right, but stepping into the reality of administration reveals a very strict, frankly intimidating protocol.
It does. Oral bioavailability for delicate peptide structures is exceptionally poor. Swallowing TB-500 in a capsule or a tablet form is highly ineffective.
Because of the stomach acid.
Exactly. The human digestive tract is a harsh, highly acidic environment designed to aggressively break down proteins. Stomach acid will rapidly cleave those fragile amino acid chains, completely destroying the sequence before it can ever be absorbed through the intestinal wall.
Which means researchers and biohackers have to rely on a format called lyophilized powder. And I found the physical description of this in the research incredibly fascinating.
It's a very specific process.
The manufacturing involves delicate freeze drying to preserve those fragile molecular bonds we just talked about. You supposedly know you are looking at authentic, high-quality lyophilized powder if it forms a pristine, solid white cake at the bottom of the glass vial.
That visual check is key.
Yeah, if it just looked like a loose, discolored mass of dust, the structural integrity has already failed.
And maintaining that pristine structural integrity requires absolute vigilance. The preparation protocols are rigorous and really leave zero room for error.
How do they even prep it?
To utilize the peptide, one must carefully reconstitute that solid white cake by slowly injecting bacteriostatic water or sterile saline directly into the vial. You have to allow the powder to gently dissolve into a clear liquid.
And then it has to stay cold, right?
Yes. From the exact moment it is reconstituted, strict cold chain storage is mandatory. Leaving a mixed vial sitting on a warm bathroom counter will cause the molecular bonds to rapidly degrade, rendering the entire batch biologically useless in just a matter of hours.
Wow. And once it is in liquid form, we are talking about needles. There is just no way around it. Administration is typically handled through subcutaneous injections.
Which is the most common method.
Right. This involves using a very fine, short needle to inject the liquid directly into a layer of fatty tissue, most commonly around the abdomen. Because fat has a lower blood supply than muscle, subcutaneous injection allows for a slow, steady, sustained release of the peptide into the systemic bloodstream.
Though some users do opt for intramuscular injections.
Driving a longer needle deeper into the muscle tissue.
Yeah, for a faster, more localized onset. Though, because of the low molecular weight we discussed, the systemic benefits eventually take over either way.
So, determining the correct dosage relies entirely on experimental, anecdotal protocols derived from the bodybuilding and biohacking communities.
Which is a whole other layer of risk.
Exactly. A typical cycle is often structured to scale down over time. It generally begins with an aggressive initial loading phase, often involving 2 to 5 milligrams administered 2 to 3 times per week.
And this high concentration is intended to flood the system and aggressively kickstart the cellular repair process for acute, severe trauma.
Right. Then, according to the regimens we reviewed, a user steps down to a maintenance phase. They drop the frequency to just once per week while maintaining that same 2 to 5 milligram dose.
And then comes the long-term phase.
Right. Finally, the research outlines this long-term phase, stretching the dosing out to once every 2 to 4 weeks. The exact math is highly variable, largely dictated by a subject's body weight and the specific severity of the connective tissue damage. But hang on a second. This is where the research hits a massive glowing contradiction.
Ah, yes. The discrepancy between the dosage charts and the safety profile.
Exactly. I was reading through the administration protocols, looking at this neat little table providing specific milligram counts for long-term use, but literally in the very next section of the same research, it explicitly and forcefully states that TB-500 is not considered safe for long-term use.
It is a glaring contradiction.
It makes no sense. The immediate short-term side effects they list seem relatively mild and manageable for someone seeking advanced healing. Some redness or irritation at the injection site, perhaps temporary lethargy, a mild headache, or a slightly elevated heart rate as your cardiovascular dynamics begin to shift.
But that explicit warning against chronic long-term use is where the reality of this biohack gets incredibly serious.
Why is it so dangerous long-term?
The danger stems entirely from the primary mechanism we detailed earlier: angiogenesis.
Building the new pipes.
Exactly.
Laying down a brand new high-speed vascular highway system. I mean, that mechanism is absolutely fantastic if you need to rush emergency relief supplies to a devastated earthquake zone, like a massive tear in your quadricep.
It's perfect for that.
But altering your body's vascular infrastructure is an absolute nightmare if a rogue element is introduced. Let's say there are existing microscopic, completely undiagnosed cancer cells somewhere in the body.
Which is more common than people think.
Right. Those cells are constantly starved for blood. If you introduce a systemic peptide that signals the body to indiscriminately build new blood highways, those cancer cells will gladly hijack that new vascular infrastructure. They'll use it to pull massive amounts of oxygen and nutrients to themselves, fueling their own rapid spread.
This raises an important question about the massive, undeniable gap in our current clinical knowledge. We are looking at a compound that wields immense biological power, yet the source data notes that the safety profile is largely based on animal models.
Animal models?
Yeah. Early veterinary studies utilizing the peptide in racehorses and laboratory rats demonstrate a very high level of short-term tolerability. They aren't observing massive acute organ toxicity in these animals. However, a racehorse is not a human being.
The long-term human data just doesn't exist.
It doesn't. Without large-scale, double-blind human clinical trials spanning decades, unregulated tissue proliferation remains a massive, looming medical concern.
Unregulated tissue proliferation meaning things growing that shouldn't be growing.
Precisely. The FDA and global regulatory bodies have not approved this compound for chronic human consumption simply because medical science does not know the long-term compounding physiological effects of constantly artificially stimulating cell migration and blood vessel growth year after year.
Which brings a harsh reality to light. Anyone choosing to experiment with this compound is actively acting as their own unmonitored test subject.
That is the stark reality.
And if an athlete or researcher decides to take on that immense biological risk, they are immediately faced with the final, arguably most dangerous hurdle of all: navigating the highly unregulated underground peptide market.
Oh, it is the Wild West out there.
It really is. The moment you start researching sources online, you are hit with a bewildering alphabet soup of different chemical designations.
Mapping out the peptide landscape clearly is essential for anyone trying to understand this field. Our research specifically contrasts TB-500 with two other highly prominent peptides, KPV and BPC-157.
Okay, let's break those down.
Understanding their distinct biological targets is crucial. KPV, for instance, is a tripeptide, meaning it consists of only 3 amino acids. It is derived from a completely different source, specifically alpha-melanocyte-stimulating hormone.
So what does KPV do?
Its primary function is profound immune modulation. It is highly sought after for treating severe gut inflammation and autoimmune skin conditions. Crucially, KPV achieves this massive reduction in inflammation without stimulating any vascular growth.
Oh, wow. So for someone terrified of the angiogenesis risk, the fear of building new highways for cancer cells, KPV offers a targeted anti-inflammatory response without triggering new blood vessels.
Exactly. It's a completely different pathway. Then you have BPC-157, which offers another distinct mechanism. It is a peptide actually isolated from human gastric juice.
Gastric juice. Interesting.
Yeah, and while TB-500 travels everywhere, BPC-157 is heavily utilized for highly localized healing. It excels at upregulating growth factor receptors, specifically at the exact site of a tendon or ligament tear.
So the user experience is very different there.
Very different. Instead of a systemic belly fat injection, a user might inject BPC-157 as close to a damaged elbow tendon as safely possible to trigger highly localized rapid repair.
Leaving TB-500 as our systemic, whole-body project manager, traveling through the bloodstream to rebuild structural fibers everywhere.
That's the perfect way to summarize it.
But actually acquiring authentic, uncompromised TB-500 is a terrifying minefield. Because this exists outside of regulated pharmacy chains, the buyer beware warnings are intense.
They cannot be overstated.
You aren't just hoping to see that delicate, solid white cake in the vial. To avoid injecting yourself with heavy metals or dangerous byproducts of sloppy chemistry, verifying third-party testing is absolutely non-negotiable.
Reputable research-grade manufacturers are required to provide verifiable certificates of analysis, or COAs, generated by independent, unbiased analytical laboratories.
And what do those COAs actually prove?
These documents are the only definitive way to mathematically verify that the vial actually contains the highly specific 17 to 23 amino acid sequence of TB-500. They also prove that the batch has been thoroughly filtered of toxic contaminants.
There is also a harsh financial reality to this unregulated market that serves as a massive red flag. The intensive process of amino acid synthesis, the delicate freeze drying, and the rigorous independent lab testing means authentic, high-quality products typically cost around $150 per vial.
Is not a cheap process.
No. So if you stumble onto a flashy website selling a TB-500 healing supplement for $20, you are not finding a great deal. You are almost certainly purchasing heavily diluted, heat-degraded, or outright counterfeit product.
Which is incredibly dangerous.
Right. The risks of angiogenesis are high enough. You certainly do not want to be injecting mystery liquids into your subcutaneous fat to save a few dollars.
The extreme price variation perfectly underscores the highly experimental, volatile, and totally unregulated nature of the entire peptide landscape.
So let's pull all of these complex threads together. We started today by trying to solve the mystery of how elite athletes seem to heal overnight, basically bypassing normal biological speed limits.
And we found a rather complicated answer.
We did. The answer, at least for a daring subset of that community, is this microscopic synthetic snippet of a natural protein. TB-500 is undeniably a potent biological tool. It possesses the incredible ability to act as a systemic project manager, rapidly ordering the repair of cellular scaffolding and forcing the construction of entirely new blood networks to heal dense tissue anywhere in the body.
But wielding that power demands a lot.
It does. It demands incredibly strict cold chain handling protocols, requires a willingness to rely on injections, and carries very real, potentially severe unknowns regarding long-term human safety, specifically the dangers of unregulated tissue growth and hijacked blood vessels.
Understanding these mechanisms matters to you, whether you are a competitive athlete desperately looking for a recovery edge, a science enthusiast fascinated by biology, or just someone trying to glimpse the future of regenerative medicine.
It really is a fascinating field.
Peptides absolutely represent the cutting edge of how humanity might one day therapeutically command our own bodies to heal faster and stronger. We're slowly learning the intricate chemical language of cellular repair.
But as of right now, in 2026, it remains an untamed frontier.
Yes. It is a powerful experimental tool that carries profound risks, requiring deep biochemical understanding and, ideally, stringent medical supervision.
I want to leave you with one final provocative thought to mull over today. This builds entirely on a warning buried in the research about how extended use leads to imbalances in the body. If you continuously introduce a synthetic, highly efficient project manager into your bloodstream to constantly build up your cellular scaffolding, what happens to your body's natural project managers?
That is a very chilling thought.
If you rely on TB-500 injections for months to survive a brutal training camp and then you suddenly stop, does your natural production of thymosin beta-4 simply forget how to do its job? Does it leave your immune system sluggish and your body far more prone to catastrophic injury than when you first started? It's something to think about.
Truly food for thought.
Thank you for joining us on this deep dive. Keep exploring the science, stay intensely curious, and always keep asking the hard questions.